Hello everyone, today I'll be demonstrating how a logbook works. Now for those of you who don't know what a logbook is, it is basically what you use to do extremely complex calculations when you aren't allowed to use a calculator. So more typically in Asia, so of course the Americans and Europeans won't know what a logbook is since they get to use calculators most of the time. But the people from India, where I am from, the science students, especially in 11th and 12th grade, might know what it is if they taken physics or chemistry as a subject. So we use it for extremely complex calculations in decimals, especially, or even if there aren't decimals. So say you have like numbers like, okay, take this again. Okay, 326.4 times 228.32 upon 5.628 times, let's say, 32.93. Now, traditionally, if you're allowed to use a calculator, this would be really easy. But if you had to use a logbook to solve it, how would you solve it? So we take the log to the base 10 to solve by the logbook, not a natural log. So what we would do first is, let's assume that it's x. So let's suppose that log x will be equal to log of this entire term. And then if we take anti-log on both sides, the log x would just return to x. But instead of returning and cancelling the log, we would do anti-log of, and then apply the property, which would go like so, as you can see here. I apologize for my setup. It was really difficult to find things to stack my phone on. So what I've done here is use the basic log properties. Like for example, in the numerator, I've used log a times b is equal to log a plus log b. And then for the denominator, of course, it will be, so this is log a minus log b. So I've just applied the negative terms to both the terms in the denominator. So how this works is, now we will begin using the logbook for this calculation. Right. So first, what you have to determine is the number which will come before the decimal point. So for example, here we have 326. So 326 is a three-digit number. Now you minus one from that three, so you have two. Now for 28, it would be, so 28 is a two-digit number. So two minus one is one, so it'll be one. And then 5 is just a one digit number, so 1 minus 1 will be 0. And then again for 32, it's a two digit number, as okay, it's a bit difficult to show. Okay, as you can see, 32 is a two digit number, so minus 1 will be 1 point something. Now we go to the logbook. So as you can see, first we have 336.4. So what we'll do is, we have two digit numbers here only. As you can see, it's only up to 99. So it's only two digit numbers, and it begins from 10 also. So what we'll do is, we have 326.4. First, what we'll do is look for the 32. So here's the 32. So what comes after 32 is 6. So in 32, we'll go up to, as you can see here, 6. So 32 and 6 will be right here, 5132. And it's not over yet. So we've done 32, 6, and then it's time for the mean difference, which will be 4. So 5132, and then a mean difference of 4 in this one would be 5. So that would be 5132 plus 5, which would make us end up with, um, it would be, okay, I kind of lost the number. Right, 5132 and 4, that will give us 5136, so it would be 2.5136. Now we repeat the same process for 28.32. So first we'll find the two-digit number, which is 28, which is right here, and then 3, which is right here, and then the mean difference would be adding 3 into this. So 4518 plus 3, that will give us 4521. On to the next one, it's 56, 2, and 8. So first we look for 56 on this side. There's 56, and then 2 and 8. So 56, and then a 2, and then a mean difference under 8. So that will be 6. So 7497 plus 6, which will be 7503. And then for the next one, we have 32.93, as you can see up here. It's out of the frame in the property section. So 3293, so 32 is on this side. First we'll find 32, and then a 9. We move forward, and we have 9 here, and then a 3 mean difference. So it would be 5176. Now these two numbers are getting added since it's 326.4 plus 28.32 minus these two. So I'll be minus. And now we just do the calculations. So 6 plus 1 is 7. That'd be 7 minus 9, which would be negative. So we'll have to carry 1. This is just basic addition and subtraction, by the way. 17 minus 9, that will 8. And then 4, that is also, I apologize for the noise in the background. So 14 minus 7, that will be 7 again. And that's negative again. We need a carry. 10 plus 5, 15 minus 6, and 9. And then 8 minus 12, that is negative again. So 18 minus 12, that's 6. And then 2 minus 1 would be 1. Right. So we have to say antilog of 1.6978. Now the antilog is pretty easy as compared to log. So you look at the numbers which come after the decimal. I apologize. The numbers after the decimal, so it's 6, 9, 7, and 8. And if you look at the antilog, it has 0.30, 0.31, so point and then basically two-digit numbers. So we have 0.69 here. So what we'll do is, in the antilog table, we'll find 0.69, which is right here, and then add 7 to it. So 0.69 plus 7. So 0.69 and 7, which would give us 4977, and then a mean difference under 8. So mean difference under 8 would be, what's the number again? 4977, and a mean difference under 8. That would give us 4977 plus 9, which is 4986. So 4986, we write that down, and after one number we put a decimal. And then we multiply it by 10, and in the power will be the number before the decimal, so 10 powered 1, which is equal to 49.86. Now let's confirm this with a calculator. Right, so I have a calculator right here. Now we'll multiply our original numbers. So that's 326.4 times 28.32 divided by 5.628 times 32.93. There seems to be a problem here. Alright, sorry for the interruption. So first we'll multiply the numbers in the numerator. So that's 326.4 times 28.32, which is equal to 9243.648. I'll just write that down. 9243.648. And then for the denominator, I'll multiply 5.628. Wait, let me just times 32.93. That's equal to 185.33. So 185.33. Now we'll divide those. So first we have 9243.648 divided by 185.33, and that's equal to 49.87, which is really close to what we got. We got 49.86. So as you can see, the logbook is can be a replacement for a calculator, but it's way less efficient. Thanks for watching this video, and I'll see you guys in the next one. Bye.